Hello and welcome to Beginners Python and Machine Learning meetup number 61. Today we'll be talking about duck typing. So on the meetup page I've provided a link to a Google Colab notebook that we can use. So if you click that link you'll get a copy of that notebook. And you'll be able to save that into your own Google Colab area. So that'll have all today's tasks in it and solutions as well. So I'll be listening on the YouTube chat and also on the Learning to Code chat in Slack. So if you've got any questions, you can ask me on any of those channels. So just a few seconds to go for the official start time. So today we're looking at duck typing, and the reason we use duck typing is because we want to write code that depends on the type of the variable or the data that's being provided to us. Python is a dynamically typed language, which means that in a single variable you can have data of different types. So especially if we write a function, then someone calling that function can provide any data type to that function, and we have to decide, do we want to handle it, or are we just going to throw an exception and say no, that's not going to work. And a lot of the times we can try to write our code so that it will work even in ways that weren't originally intended, and that makes it a lot more flexible for other people who are using our code. So if we look at our Google Colab notebook, this is just a Jupyter notebook, so you could run it in Jupyter notebooks as well if you want. Let's start. So I'll by pressing Shift Enter, it runs the cell that we're in. So the first thing we'll do, we'll just import sys and collections, which we'll be using later on in the notebook. And yep. Okay, so let's look at some of the simple data types that we've used in the past. We've used integers, floating point numbers or real numbers, strings, lists, tuples, TF. So we can find out what the type of any value is using the type function. So I've stored different types into these 7 variables, and now if I print the type of each one, it tells me that the first one is an int, the second one's a float, S is a string, LST is a list, T is a tuple, TF is a bool, which is a true or false, and D is a dict or dictionary. So you might think if we wanted to find out, if we wanted to have code that depended on what type something was, we could just check the type, and if it's the type that we're thinking, then we can use it. So that makes sense. Here's an example. If we want to test if S is a string. So we call the function type S and we compare it to our string type, str, and if it's true, it'll print S is a string, and if it's not, it'll print S is not a string if it comes out false. So I'll run that, and that prints my string is a string, is an str. So yes, that does work. You'll notice when I've used this print statement here, I've put this exclamation R after the S, and that just says do it as though I've run REPR on the variable, which means show me how it's internally represented. And so what it's done here is it's put the quotes around my string, so that gives me a little bit extra information about the data type that I've got. It's telling me it's a string as well, and I've just done that to make it clear here. All right, so our task 1, we're going to loop through all the variables and find which ones are ints. Okay, so we're going to use the same technique. If the type is equal to an int, then we'll print the value is an int. So the first thing we need to do is create a loop, and I'll just put all the variables into a tuple here. So it's just I, F, S, LST, T, TF, and D. And I want to say if the type of that variable is an int, then print v is an int. Okay, so we'll run that, and that's come back and it's told us that 35 is an int. So it's looked at all of these data types and it says there's only one int in them, and that's the one 35, which is stored in the variable I. So let's have a look at my solution here, which I previously created. I've written it a bit differently. I've used the inline version of if, and I've put it all inside the print statement. So it's a little bit harder to read, but I managed to get it all down into 2 lines, and it tells me a little bit more information. So let's run this one, the solution. So it says 35 is an int. It is a int. So if you look at this bit here in a format string, it's a format string because it's got the F out the front. We've got the curly braces, and in the curly braces we've got this if statement. If type of v does not equal int, then we want to use the word not. Otherwise, just use space, a blank. So that's useful if you're trying to do a condition all in one line, and you need to know whether it's you return one of 2 results, one if it's true and the other if it's false. So I'll just show you an example. I'll just create another cell. Yeah, if I click in here, Command M, B, yep. So I want, so let's give me a string with the word true if 4 equals 5, else false. And so that's come back with a string false. So it's looked at this condition, and if it's false, it gives me what's on the right hand side, and if it's true, it gives me what's over here on the left. So let's do that again with the left and right, and we can change the condition here. Let's change that to just true. So if it's true, it uses the left, gives you the left value, and if it's false, it gives you the right. And it's sort of English speaking. You say the answer is left if whatever this is, else give me that answer. Okay, what does done to name do? So when I, let's do another. When I was setting up this print statement here, I wanted to say it is a int, but if I tried to print the type of an integer, it gave me class int, and I didn't want that. I just wanted the word int. So this gives me the int class, and then I just want the name of that class, so I do dunder name there, and that tells me int. So I've got here the variable, how it's represented. So integers are just represented without a decimal point, floats are represented with a decimal point, strings are represented with quotes around them, lists are represented with square brackets and commas between them, tuples are represented by parentheses and commas between them, true and false, the bools, true is represented with a capital T, R-U-E, and false is with capital F, F-A-L-S-E. And dictionaries are represented in curly braces with each key before a colon and each value after the colon. And the keys can be any immutable hashable character or any mutable hashable data type, such as integers or strings or even tuples. And these are strings, our values, and they're all strings. So that's not an int, it is a dict. Okay, any more questions? So in this line, what have I explained? That there's the dunder name for the type, there's the inline if statement, and there's the value, how it's internally represented. And I've put them all into a format string. Right, so were we happy with that? That's given us, it's looked through all those variables and it said only one of them is an int, 35. Well, that's probably true. Well, let's look into that a bit more closely. So when we are looking at the types of a class, we use the type function, as we've done. So the type of TF is a class bool. Now, when we do classes, they are based on a superclass. So that if we write a class and we base it on a superclass, we don't have to rewrite all the code that's in the superclass. We just inherit all the superclass code. In fact, you can have more than one superclass in Python. In Java, you can only have one superclass per class. But Python does multiple inheritance, so it can get the code from lots of different classes. So we want to find out what the superclass is of any of these classes. So let's look at the base classes or superclasses of bool by using this double underscore bases double underscore. And we call these double underscores as dunder. Okay, so I'll run this code. And it says the base classes or superclasses of bool are int. So bool is a subclass of int where true equals 1 and false equals 0. So any of the other classes that we looked at, so I'll just do a new one here. If we wanted the base classes of int, it's just object, and same with list, spelled properly, it's just object. So most of the classes there are just based on object, which is the generic class for everything. But bool, rather than writing bool with everything that's in int, they've just subclassed int so that it becomes bool. And so it's got all the behaviors of ints, except that it's only got two values. It's got one value called true, which is equivalent to writing 1, and another value false, which is equal to 0. Now, we're not going to look at the source code of bool to see how they've done that, but we can look at some of the results of that decision. So if we calculated this, what is 5 minus true, it tells us that it's 4. So it's just considering true to be an int with a value of 1. And similarly, we say what's 4 plus false, is 4 plus 0 equals 4. Right, so even though bool is an int, when we said is the type of bool equal to int, it gave us false. It said it's not. So what we can use, there's another function called isInstance, and that allows us to check if it's either its class or one of its superclasses is equal to the one we're checking for. So in this case, we want to see if our TF variable, which is a bool, is either its class is int or one of its superclasses is int. So let's have a look at that. And that returns true. So we can use isInstance to check the class hierarchy. And so that could be more useful because we want to know when we're writing our code, does it behave like an integer? So we just call isInstance rather than is it exactly an integer, which is what type equals int was doing for us. So to run some demonstrations here, I'm going to pull up some extra classes out of the collections library. This is a standard library that comes with Python 3, and it's got these classes in them. So there's dec, which is a double-ended queue. There's named tuple, which is actually, well, named tuple is not actually the class. What it is a class generator. We can create tuple-type classes that have named attributes. So it can work similarly to a dictionary. We've got default dict, which is like a normal dictionary, but we also provide with it a default factory method. And that default factory method will be called if the key doesn't already exist in the dictionary. We've got counter. So what counter will do is it'll look through an iterable list of or sequence of items, and it will count how many of them there are and create a dictionary type object that tells you for each of the items how many were in the sequence that's been evaluated. And chain map allows us to use default dictionaries, two dictionaries, and it will look in one to see if it can find that key, and if it's not in that one, then it follows the chain through to the next one and sees if it's in that dictionary. So don't worry if you don't remember all of that. Let's have a look at some examples of each one of those so that we can see just how we would use them. So I've put them all in here. We're going to create a double-ended queue. So I've used as my object that I'm creating it from, I've used a string. So just as I'll do, so I'll show you what that would do if we did it with a list. So if I wanted to create a list and I did it on a string, so let's just use queue. In fact, we can use single-ended. Queue. So it's created a list by iterating across the string, and we've got one value, one letter as each item in the list. So because string is iterable, you can iterate over the characters in a string. It then can create a list from that with each character in it. So that's what we're going to do with dec. Dec's going to do the same thing. The string is going to be called double-ended queue. So it's just going to get a lot of single character strings all in a list-like object, but it's going to be a dec object, and dec has specific capabilities that allow you to pop and push items on and off at each end of the list with high performance. So you can do that with a list. It's just very slow when you're doing it at the beginning of the list. It's quite fast if you're doing it at the end of the list. But a deck is a double-ended queue, so you can put them either at the beginning or the end, and as you're adding them, and you'll still get good performance. All right, so I've just had a question. What does V exclamation R do in a print statement? So I'll do an example of that. So if V is equal to my what's a good example? Well, we'll do a list. Okay. And then if I want to print that, this is going to give me the same. Yes. All right. Let's just go with a string, because that will be different. So V is a string with the letter A in it, and if I print V, it just prints the letter A. Similarly, if I do that inside a format string, I'll also get just A. And that's what we want, because normally when we're printing the value of a string, we store the strings internally, and then we're using them for our output in our reports and stuff, and so we want them to print out exactly what the characters of the string are. But in this example I'm doing, we are more interested in what the data type is, not how to print an A, the letter A. So I've put in exclamation mark R, and that says, tell me how it's represented. So if I do that, it's internally represented with as a string, and so the way you do strings is with quotation marks. Now that would be the same as if I had used the function repr. So that's what exclamation mark R is doing, is running that function repr. Now say I had, that was a set. Let's try that. Set, got 3. Let's say V is a set, and we're going to add 2 elements to that set. Yeah. So and I print V, and it prints out like that. And if I print with an exclamation R, it prints the same. So I was hoping it was going to tell me that that's a set rather than a dictionary, but I guess you can tell from that it's a set because it's got the curly brackets, but it's got no keys in there, so therefore it's a set and not a dictionary. Okay, so we're doing a deck is going to be our double-ended queue, and we'll do that. So let's just run this, and we can see what it's going to produce, and then we'll go through the other lines. Deck is not defined, and that's because I didn't import it. So let's import it by running that one. So deck, it prints out, as you can see, it looks like a list with all the single character strings in it. but it's got the word deck out the front so that we know that it's a deck and not a list. Named tuple, so we've created a new class called point, and then we've created from that a new variable of type point with 2 values in it. And when we print it out, see we've got named values for this tuple. So x equals 1, 2, 3 and y equals 4, 5, 6. So you think, well, that looks similar to a dictionary. It's got a value, and each value's got a key that identifies that value. Then we've got a default dictionary. So we're going to create a default dictionary, and we're going to use the list constructor as our default factory item for the list. So that means that when we say dd for a key, and that key doesn't exist, it will put an empty list in there. And then we can append to that list. So let's have a look at, I'll just do a cell below, and we'll do an example. I'll just call it dd2, default dict list. Okay. And we'll have a look at what's in dd2. And it's just a default dictionary. It's currently got nothing in it, and it's based on list. So now, if I say tell me what's in dd2 with key of A, it gives me an empty list. Now, if I tried that with a normal dict, dd3 of A, and in this notebook it's only going to show the last thing that comes out, but it's going to say there's a key error because it doesn't exist. So what this is doing is whenever we call something that doesn't exist, it returns the default value that we got created, which was the list constructor. So it creates a list, and that means that we can after creating it, we can append stuff to that list. So let's append a value and then have a look at what's in. We'll do another value, and then have a look at what's in there. And so that's this part here creates the empty list, then it appends 1, 2, 3 to it. This one here sees that the list exists, so it doesn't create an empty list the second time, and it appends 3, 4, 5, and we look what's in there, we get the list 1, 2, 3, 3, 4, 5. So what we're going to do is we're going to look at each one of these classes that we've imported from the collections library, and we're going to find out what the bases are for each one of those and use those bases as the keys. And then, so the names of those bases will be the keys, and so we'll see what has been, for each of the base classes, what of these collections classes depend on them. And so if we look at the result, we say if list is the base class, then what depends on that is, that's our default for default dictionary. If object is the base class, then what depends on that is deck. If dict is the base class, then that's depended on by default dict and counter. If mutable mapping is the base class, then that's depended on by chain map. And if tuple is the base class, then that's depended on by point. So we'll come back and look at those later, and we'll just finish off these other classes just to see what they do. We've got counter. It's looking at the letters in the word Indooroopilly, and it's just counting how many of each one there are. So there's 4 O's, 2 I's, 2 L's, 1 N, 1 D, 1 R, 1 P, and 1 Y. And chain map, I've just taken the default dictionary we created in DD and the counter dictionary, which we created with counter, and I've put them in a chain, which means we can now look up anything, use any of the keys from DD or CTR. Now, of course, chain map won't work with anything that returns default values, because the whole point of it is it looks at the first one. If it can't find something with that key, it goes to the next one. But if it's got the default value, it will always find something for that first one. So I've had to convert them from this default dict to just a normal dict by putting it in the dict function, and similarly CTR, which also works with defaults. I had to put in the dict function, although because it's the last one, I didn't need to do a default for that one, because there are none after it that wouldn't get called. So if I look at chain map now shows you all of those things. It's got object, just like this key here is the same as there. So all of these ones here are from default dict DD, and then all of these ones are from the counter CTR. And I can look up something in that chain map. So if I looked up I, it will look through DD and say, oh yeah, there's no I's in DD, so it'll go on to CTR and go, oh yeah, there's an I key in CTR, and return the value 2. Similarly, if I looked up something from the first one and say, with a key of dict, what do I get? I get a list of these names, default dict and counter. So they're the ones, and they've come from DD. Okay, let me know if I'm going too fast or you're getting confused with this stuff. So let's look at task 2. So I want to loop through the values DQ, P, DD, CR, CM, and find which ones are instances of dict. So remember, we've worked out that we can use the isInstance command or function to work out if something's an instance of it. So for V in, we'll do the tuple of all the variables we want to look at. CM, which one's instance of dict? Okay, if is instance V of dict, then we'll print okay, so that's given us the default dict and the counter have come back as dicts. Now that's a little bit surprising, because well, I would have thought that chain map would come back like a dict, because you can do the things that we're trying to do, which is look up a string-based key on chain map, but it hasn't come up as a dict. And we can actually see that the default, the basis of chain map is mutable mapping and not dict. So isInstance is useful for some things, but it's not giving us the information that we need all of the time. So let's have a look at my solution here. I've done a very similar thing for variable name in, and I've done the variables as strings here, the variable names as strings, and then I've got the variable from the string name. And this is the reason I've done that is so that I can print the variable name in my print statement. Because up here in the solution I've just done, I didn't know the variable name. All I knew was the value, because that's all that was stored in V. So this is a useful trick. Globals tells me all the global variables at any particular time. There's also another function called locals that will tell me all the local variables when I'm in a function, and I can look each one of them up by a string of the variable name. So let's run this solution and see what it comes up with. And it says instance of dict dd. So the variable name is dd, and then it's printed out what the value is. The variable name is ctr and what the value is. So they've both come up as dicts, just as we did before, but not chain map. Okay, and as we've seen, the problem is we can use chain map with a string like index, a string index, and that works, but it's not a dict. And really, if we're writing a function and we need to know what type it is, we don't really need to know what that it is a dict. We just need to know that it's going to behave like a dict. So, and this is where we use duck typing. Basically, it comes from the saying, and I'm paraphrasing this, if it quacks like a duck and walks like it's duck, then as far as we are concerned, it is a duck. So what we're interested in is the behavior of the item, and then we can use it as it's something that behaves like that, because it's only that behavior that we're interested in. Some people would say it's also easier to ask for forgiveness later than permission first. So to do duck typing, what we do is we try to use a given data type, assuming it's the correct data type, and then if that doesn't work, then we basically ask for forgiveness and we say, well, let's do something else with it. Okay, so let's look at some of our objects. Default dict is a dict subclass, so we expect to be able to use a string index on it. And here's, so dd is our variable. We've got the square brackets, and in there we've got this string, the word object, and similarly with chain map. So dd of object gives us dec, that's correct. cm of object also gives us dec, so they're the values in those dictionaries. But we can't use string indexes on lists. We all know that, and what happens if we try to is we'll get a type error. So I've commented this out for the moment, but I'll remove the comment and I'll try to run this. And you see it gives me a type error, because what I've done is I've used list here, which is a list, and I've tried to use this string key on it, and it's going list need a numerical index. So it's giving me the warning here, list indices must be integers or slices, not strings. So the way we do duck typing is we do what we're trying to do, which is we use the string key for our list, and if that doesn't work, we get the type error. So we say we try to use it as we're doing, and if it doesn't work, we get if the type error gets raised, we catch it. So we say except if there's a type error, then do something else. So I've put in a lot of print statements here, but I'll do it again without all those print statements so that you can see exactly what's going on. So we've got try, we do what we're trying to do, which is grab the value, and we're probably going to store that in a variable. And we'll do that unless, except if there's a type error. If there's a type error, then print will do something else. So in this case, we're going to print whoops, there was a type error. And yep, whoops, there was a type error, but we don't, the program will keep running. If we have a program like up here in line 45, and we get a type error, the program will stop and say, look, there's a problem in the code. It wasn't expecting it, and so we're not going to continue. But if we put it round a try and accept, then the program code will keep going. Now, there are different sorts of errors that you can get here. So if I said key error here, and try running that, that'll still crash with the type error because we didn't catch the type error, we just caught the key error. All right, so let's run it with the print statements in here. And it's doing the same sort of thing. And we go, it tried to print this, but it threw an error, so it didn't even print anything out. What it does print out is this second line, which is list, LSD is a list, and so we can't use a string index, which is all the words that we've put here. So this is an example of duck typing. So we'd often use duck typing in functions, function definitions, because we have no control of what data types other programmers send to our function. When they call our function and they have to provide parameters or arguments to our function, they can provide all sorts of things. And so we have to decide which ones we're going to handle and which ones we're just going to throw an exception. So looking at task 3 here, write a function O-value which returns a dict value with index 0, O, or if not a dict, returns, let's see, it returns a value with index, I guess it's the value of a dict with index 0, or if not a dict, like then a value with index 0. So that's O or 0. Okay. So we're going to define our function. It's going to provide a variable with a value in it, and we're going to assume it's a dictionary. So we want to just return with a key O, but that might throw an error because it might be a list that they've given us, in which case we're going to return a value with index 0. So we'll try that, except if they've sent us the wrong type, in which case we'll try to send them a value with a index 0. So let's test this. So if I send them a dictionary, well, we've got a dictionary, what was that, counter, CTR. And it gave us 4. So there were 4 O's in Indrapilli, so it's given us a value of 4 for that. So let's try default dictionary. It's given us the empty list, which is good. So default dictionary provides defaults. It didn't have the key O in there, but it because it had it was a default dictionary, it still provided us with an empty list. Let's have a look at list. That came back with a 5. So I think, I can't remember what was in list. Let's print list. Oh yeah, so list was 579. So the 0th item in list is 5. Okay, so let's have a look at this solution. It does it for every one of those variables, including the string. So we didn't design this for a string, but maybe a string will work. Let's see what happens. So O value of the list is 5, which is the 0th item out of 579. DD is the empty list because it's a default dictionary and it doesn't have that key of O or 0. Well, O, it looked at O first and it goes, yep, it'll return the empty list, so it never even looked at 0. The chain map, it checked the first dictionary, couldn't find it in that, so it checked the second one and it got the value of O out of that and returned the value 4. It looked at the deck, so the deck doesn't have named keys, so it would have thrown an exception here at type error, so it would have used this 0 index, and in that case it's returned the single character D. And then the string, so we write a string, we weren't even thinking someone was going to give us a string, but the string was my string, and it can't do a string index on that as like a dictionary, but it can do a position index using an integer. And that goes, so it's taken the 0th position character out of my string and it's returned an M. And so that's probably going to be useful for something. So people now are able to use our function O value with strings, even though we didn't write it for strings, but because we wrote it in a way that it would, we just use duck typing, it can actually be useful for them. All right, so Leo's asked, can we have multiple accepts? And yes, we can. So I'll go back up here to looking at our try statement. So let's use a dictionary. What was our dictionary? We had one called D. Right, so it had these values in it. So let's say we wanted to find D of B, and except if there's a key error, we do that. Print, whoops, there's a key error. So print D, that's D, V equals D of B, which should have returned O, but I'm getting a key error. So let's try oh, B is the value. It's not the key. There we go. So that's good. It gave us the right error. So if I did O there, then O has a value, and so that's now stored in V, this value. Okay, which we can see it's stored in V, and I've just printed that out. So there's two sorts of errors that could be happening here. We could have a key error or a type error. So we can put in multiple excepts here. A type error. So if we did LST, we got a type error. If we did D of B, we got a key error, and yeah, so you can do multiple accepts. Okay, with duck typing, wouldn't that mean the developer would have to cater for all possible scenarios, else the program will fail? And yeah, that's really the point, is you cater for as many scenarios as you think are useful, but you don't have to cater for all of them. You can letting it fail is fine, especially if you've written a function and you've put in your function that they have to provide either a list or a string, and they go and provide something else like an integer, then it's quite acceptable to make the program just fail at that point. So in that case, you throw an exception, and you can raise your own type error. You say raise a type error. You've provided the wrong data type to this function. The advantage of duck typing is if you say I want a dict, and they provide something else that does just about everything a dict does, but is not a dict. And in fact, it does it in such a way that it's useful to you as the writer of the function. You can still use it. Then you use duck typing. You don't go, look, you didn't give us a dict, I'm going to raise a type error and stop the program. You go, okay, you didn't give me a dict, but I will work with it. I'll work with what you gave me, and we'll see if we can keep going with that. And so don't feel like you have to handle every single data type that exists, but with duck typing, you're not restricting yourself to really specific types, because you can see here we've got a whole lot of types that all look like dicts, but they're not. Some are dicts, some aren't dicts, and so it's but we're able to use them, and it really makes no difference to us. Okay. All right, so I've looked at solution 3. Task 4. So the problem with our O-value function is that it won't work with something which can't be indexed, for example, an integer. For some situations, this will be the desired behavior, which is I've just described. In that case, you do want to raise an exception and say, no, you've given us an integer, we don't want to work with that. So you'll have to do something about that and send us the proper data next time. And if you raise an exception, the programmer who called your function, they can use a try and except to catch the exception that you raised on their code, so that they can see if they think that they can continue to work even though you haven't completed your function. Then it's up to them to write that bit of the code. Okay, yes. However, in our situation, we've decided that we do want to handle integers. And what we want to do is if it's a different type, we want to convert it to a string and return the first character of that string. So if someone calls, so let's see what happens if they call O-value of an integer at the moment. Int object is not subscriptable. So it tried running var of O, and that raised a type error. So went into the accept the type error, and it said var of 0, and then it's going, hang on, var of 0, that's not subscriptable. We're going to throw another type error. So even though we were in the accept type error, another type error was raised, and that's stopped the whole program. Okay, in fact, if you read the whole error up here, it goes, the int object, during handling of the above exception, which is this one here, the type error, another exception occurred. So the handling is what's in the accept type error clause, and that's where a second exception occurred. All right, so we have to, what are we trying to do? Return the first character. So we'll get our function. And we're just going to modify this. All right. So what I like to do, we can nest the try and excepts, but I don't like it when the code starts getting a lot nested. And we've got, in the try, we've got a return var 0, var O. So that means that there's no other code that's going to be run after the except has been handled. So really, I could just as well put a pass in there and then return var 0. And that's the same, that does everything exactly the same as how we did in the previous function. You have to have something in this except clause. So I've just put a pass because a pass is a do nothing statement, but it's still a statement. So it has the indentation as we expect in Python, and then we move on to the next statement. So what we want to do is we want to put this statement into another try and except. So this one, once again, is a type error. And that was the int object is not subscriptable. So in that case, we want to convert it to a string. And then return the first character of that. And so let's test that. Yep, so if you remember, I was 345 or 35, and so it's converted it to a string and then take the first character. So that's how we've defined our function. And let's compare it to the solution. Yep, it's the same as the solution. So let's run this new function we've created, oValue, and we'll run it over all our variables. We'll create a few new ones and see how it handles them. So we've got none, so that's a variable with no value at all. We've got an empty string, and we've got an empty list. And we'll see. So we're going to call the oValue function, and oValue's got some tries and excepts in there, but it's not catching every particular case. So what we do is we put a try and except around everything, our calling of the oValue. Now, in our case, I'm just going to catch every single exception there is because I don't want it to stop and I don't know what the exceptions are going to be. This is bad programming technique. You don't want to do this normally. You'd only ever do it in something that really does not matter in your code if there's an exception happens. In fact, you'll get warnings in your code if you're running PyCharm as an IDE. But anyway, we'll do it. And what they say is if you are going to do this, so except with no specific sort of error, just catch every error, then at the end you'll want to do a raise. And what raise will do is re-raise the same exception that got thrown, but you've been able to do something in the meantime. But I don't want to do that. I don't want to raise it. I want to run this and see what happens. So as I run this code, it works on everything. It even works on my integer. It works on the dictionary, on the none value. It's converted that to a string and taken the letter N and returned an N. I go, okay, is that what I wanted? Maybe it is. But for the empty string and the empty list, we're now getting index errors being thrown. String index out of range, list index out of range. And you can see I've used, remember before I imported sys, and sys gives me this exception info, which is a list of different pieces of information. So the first, in the 0th index of exception info, it tells me the class of the exception that got thrown. So index error is a class, and I just want its name. So rather than class index error, I'm just getting index error. So it's showing that. And then this, the 1th index of exception info gives me the message, and the message is string index out of range. So this exception that got thrown while O value was being called, I've called it in this except clause, and I've printed out, I'm able to use that in my error report, which can be useful if you're writing a report to the user. I think it's better to give them a confusing exception error description than to give them nothing at all, because at least they'll know that what they're looking for. So string index out of range, they won't really understand what that means, but at least they've got something. They'll think, well, string any text, is there something they've answered an empty string to that they should have put a value to? Or they can call up the programmer and say, oh look, I got this string index out of range. He'll look at his code and go, oh well, to get that you must have provided an empty string. And they'll go, oh yeah, I did. I didn't think I needed to answer that question. And so at least they'll make some progress if they're told what the description of the error was. So those functions can be useful for that. Right, but it's highlighted that we're now getting index errors, and is there something that we want to do in that situation? If the index key doesn't exist, we can throw a key error, or we can provide a default value. So let's have a look at a couple of examples of dictionaries when there's we use a key that doesn't exist. So rather than object with a C, I've done object with an X. That doesn't exist. So let's see what happens when I call that on DD, which remember is our default dictionary, and CM, which is our chain map. Okay, so DD, the default dictionary, that returned an empty list. Chain map, I've got an error here, and it's telling me I've got a key error. The key OBJEXT doesn't exist in the chain map anywhere, so it's going to give me a key error. Right, task 5, OValue function, it should return none in the case of a key error or an index error. Okay, so let's copy our OValue. So if we get a key error, we can get a key error here. In that case, we want to return none. And an index error. So the index error, that's going to happen if we've got a list. We try calling the 0th item on the list or the string, and it's out of range. So in that case, we'll get a key error, an index error here. So we want to return none for that case. Okay, and we'll get our code for, we'll just grab that code to test our function. And yes, our empty string returned none, and our empty list returned none. Now there was something that was supposed to be returning a, we weren't getting any key errors before, so we're not actually testing key error. So let's try something that does a key error. v4 equals, so I'll do a dictionary with just a 1. That'll do. And A1, if we're trying to find the O value of A1, this dictionary, we get none because of we're now handling the key error. So let's have a look at our solution that was provided by me. So for the dictionary, we've decided to use this get function. So get is a built-in method of the dictionary object that allows you to get a value if the key exists, and if the key doesn't exist, then to return the value none. So in this case, var.get of O, it should return, it'll look up that key. If the key doesn't exist, then it'll return whatever's here. And yeah, so this is an interesting situation. So I'm just going to do we'll have a look at what the different things that could get returned here. So if I had my dictionary, we've got v4, that's a good one. So if I said v4 of O, that gives me my key error. Now rather than doing v4 for key O, I can do v4.get. And now rather than square brackets, I have to use parentheses. What will this do? There we go, and I should print that so I can see what it gives me. And it gives me none by default. So I can get O, the key, using the key O, and if it doesn't exist, it'll just give me a none. So get does actually what I need. It doesn't. I don't need to check for a key error in that case, or I can actually just return something else as a default. So get is for getting an item out of a dictionary, and if it doesn't exist, then return a default. All right. So let's print v4 at the beginning so I can remember what it is. Yep. So I could just have left it like that. And so I'm going to, if I, so if v4 was a list instead, and I try running get on the list, I don't get the type error that I did before. I now get an attribute error. So what I've done here is I've caught the attribute error and then gone on to handling it as if it's a list, because it's not going to give type errors anymore because I'm using get. Then I looked at my function. Maybe I had v4 was a dictionary, and it had a key of A, 5, and a key of 0, 67. So according to our definition for our function, that should return 67 because it should check first for the key of O, and if that doesn't exist, it should look for the key of 0. But as we've written it, it will return none. So what we're saying here is if the O doesn't exist, then look for the 0. And if that doesn't exist, return none. And that's where this code came from here, var.get O, var.get 0. So both of those cases are looking for dictionaries or dictionary type objects. And then if they fail, then we look at list or strings. And if that fails, we convert to a string and run it again. And if we still get an index error, then we return none. So that's what this is. Let's have a look at that. And you can see here I've used the raise because I'm pretty sure I'm not going to get any exceptions at this case. That's right, I didn't Any questions so far? Right, so the full structure of try except is illustrated in this example here, which is a function called divide. So you put in your try code block. What it is you're going is the bit of code that could raise an exception, and then you put after that the different exceptions that could be caught. So it could be a zero division error in this case. We can put it in as, it could be an attribute error or an arithmetic error. And you can have several more except clauses. So we've got one try followed by 0 or more excepts. You don't even need to have any excepts if you don't. Then you have an else if none of the exceptions were raised, in which case you can say print the result is that. And then finally, you can have something that you want to run regardless of what happens up here. If an exception happens and gets caught in here, you want it to also do what's in the finally clause. If no exceptions happen, you want it to run this, and then you want finally to happen. If an exception occurs up here that's not even in your list of exceptions, then you still want the finally to happen. So let's run this code. So we're going to try dividing 5 by 2. That should work. So we should just say result is 2.5. We try to divide 5 by 0. That should throw the zero division error. And if you want to do something with that return object from the zero division error, you can store it in a variable here. So I've stored it in ZDE, and we can do something with that. That's pretty good, useful if you're logging these errors. You can log the exception in your logging command. Then we're going to try dividing a string by a string. Now that's not going to cause any of these exceptions, so it's going to raise an exception on its own. So let's see what that looks like. Right, so the first one, 5 divided by 2, result is 2.5, executing finally clause. So this finally happens every time. Then we do divide 5, 0. That gave us a zero division by error. So we've printed division by 0, and then we execute the finally clause. Then dividing the string 5 by the string 1. That throws a type error because the slash is unsupported for between string and string. So the whole function returns with that exception, except that it runs the finally. It always runs the finally. And the reason you have finally is often for things where you have to close resources. So for example, if you've opened a file that needs to be closed, and you have some exception that gets thrown, you know that the finally will always be run, and you can close the file in that case and not leave files open. That's just one example. Okay, so executing finally clause. Now another interesting thing here, zero division error, that's a class which is a subclass of arithmetic error. So if we don't have the zero division exception being caught, and we run this same code, then this arithmetic error picks it up, and we get the printed statement either an attribute error or an arithmetic error other than zero division. Well, it's saying other than zero division because zero division should have been already caught up here, but because we're not catching it, then it's that's not actually true. It's an arithmetic error. So I'll leave that as it is. Right, now you might have used other languages like Java, and Java tries to achieve this sort of functionality using interfaces. So an interface is not a class, it's just really particular behavior of a class. And when you define a class, you have to say whether it implements that interface. Java is providing a little bit of that concept of interfaces, and they're doing it automatically, so you don't have to declare that your class is an implementation of a particular interface. They've created some interfaces that automatically look for the existence of particular methods, and if that method exists, then it says that it implements it. So in our collections library, in collections.abc, which is abstract base classes, we import the mapping, and that's really an interface. And what it does is it checks for the existence of getItem, which is what we've been doing in our functions. So if we run that on these 5 different variable types, then we see that the 3 that are instances of mappings are default dictionary, counter, and chain map. So chain map is an instance of mapping because it's got that getItem function in its class. So this, you could have used isInstance in this case if you used an interface, and it would have worked. But they still say in the Python documentation that the duck typing is probably a little bit more reliable than using these interfaces. But I thought I'd let you know that they exist. When we're using dictionaries, we use these square brackets. But all the square brackets are, whenever you use them, it's just shorthand for calling the getItem method, dunder getItem. So wherever you use square brackets, you could also use dunder getItem. And here's an example of doing that. So cm square brackets object gives us the list deck, and similarly cm.dunder getItem dunder of object also gives us deck. And so that's how libraries like Pandas have implemented incredibly complex functionality with the square brackets, is that they've provided provided a getItem function that handles whatever we put in the square brackets, and it looks like we're using Python square brackets, but we're really just using a getItem and we're using it by using a shorthand. Okay, so task 6, we're going to define a function stutter, which returns a string made of every iterable item doubled. If not iterable, then we're going to convert it to a string first. And the way we test whether something's iterable is we pass it into the iter function. So here's some examples. We want stutter hello to return a string with every letter doubled. We want stutter AB for a list to return them all as a long string with each item doubled, and an integer we want it converted to a string. So this is an example of how to use duck typing. So it's just reinforcing what we've learnt already. So let's have a look at this iter function. So if I say iterator equals iter of a string ABC, and see what iterator is. So it's a string iterator, and then what I can do with an iterator is I can say for C in iterator print C, and that's printed A, B, C. Okay, if I do it for a list, that'll do. Prints A, then B, C. So it shows that it can be iterated on. If I do it for an integer, 3, 4, 5, then I get a type error. So here we got an example. We're trying to do one thing. If it doesn't work, we can catch it and do something else. And what we have to catch is a type error. Okay, so that's good. So let's define our function. It's going to be passed in a value. We want to create an iterator, see if it's going to be iterable. And if not, if we get a type error, then we're going to convert it to a string and then run the same function. So we can do this like a recursive function. All we have to do is return stutter of the string of the value. Okay, and then so let's create an empty list. Let's call it stat equals an empty list, and then for C in the iterator, start dot append C, and then we'll just return. So we should convert them to strings as we're appending them. And then we are going to join all the strings up. And we can do that just by, with an empty string, call the join function and pass it the list. Okay. So we want to print stutter hello, print stutter and we'll do that. And yes, we wanted them to append twice. So that was the whole point of the function. So there we go, we get the right answers. Yes. All right, in our solution, looks pretty similar. I've just converted the string once, so I didn't have to do the string conversion twice. So it's probably saved a little bit of time by doing that. That's probably slightly faster. And the rest of the code's pretty much the same. Let's see how it runs. We've got a few different examples here. We've got stutter 345, we've got stutter with a string 345. And none gets created to NNOO, So that that works. All right. Task 7. Create a subclass of string called JavaString, which can be used in expressions like JavaString plus int. And what we're trying to do is overload the plus operator. So in Java, if we had a string ABC and we appended it to another string, we get ABC3. And in Python, we get the same thing. Now, if we try doing that with a string and an integer, we get must be a string, not an integer. So sometimes that's a really useful function to have. So why don't we create our own string function, our string class. We'll call it JavaString, and it will have that behavior. So let's see how we would do that. The first thing we want to do is create a class, and we're going to call it JavaString. And that JavaString is going to inherit everything that the string class already has, except that it's going to have this extra behavior. So we have to implement a function that's going to let it work with the plus sign. And that function has got the special name double underscore add double underscore. And it means we're going to add this Java string with something else. Right. Now we could just return self plus the other. And if that works, and that'll be for the case where we're trying to add string to string. But we want to catch the case where there's going to be a type error, in which case we're going to return something different. So in that case, we're going to return self plus, we're going to convert other to a string first, and then we're going to add them together to concatenate them. And what I should do here, we're not actually going to call plus, because plus would call the same function that we're in, so we'll just get a recursive loop here. So what we're going to do is call super from the super class self, and self, there we go, of other. So super is the object, is this object, but as the but using the methods from the super class with other. Okay, and this is going to be super dot add string of other. All right, so let's try to create an object of that class. We use the class name, parentheses, and our initiating value, which is going to be the same as the initial init method of str. So let's see how we go with that. So that returns ABC plus 3. So that's all very good. Let's print. Oh yeah. So what I'm going to do is store that in a variable equals Java string ABC. And we're going to print JS. So it prints ABC, and we want to print it as it's represented internally. So we get the quotation marks. And what we really do, we want to know that it's not actually a normal string. We want to know that it's a Java string. So what we should do is overwrite another method so that it prints out Java string. So it tells us pretty much what the type is in the when it gets returned. So Java string, and there we can just put in self. That'll do. Okay, and I better spell this right. There we go. So now when we use the exclamation mark R, what it does is it calls the internal method of the class REPR and shows us that it's ABC. Okay, so let's have a look at what print FJS plus 3 is. and with an exclamation mark R. Right, so this is our new class. We've implemented add, and we can now add a 3 to it, and it will add it into the long string. One of the problems in what it's returning is that it's returning a, because we're calling the super actually returns an str, it doesn't return a Java string, and then that's getting returned. And so here the result is a normal string rather than a Java string. And you might think, what's the problem with that? And I'll show you what the problem with that is if we then try to add extra things to it, we'll get an error because it calculates that first, and that's now no longer a Java string, it's a string, and we try adding 6 to the normal string and we get the error. So what we have to do is we make sure that this returns Java strings. And that's good. Now it all works. We always get a Java string, and we get ABC36. So let's have a look at the solution that I had here. Yep, all looks good. It's pretty similar. Rather than using str of other, we've used a format string down here for the other, and we're returning Java strings. So that's all good, and the +5, +4, that all works, I think. We'll just run it to check. Yep, gives us leading 5, 4. So this is working with a leading string, and so if the string comes first and then an integer, this will return it as a full string. Unfortunately, it doesn't work if we say 56 plus JS. So the add only works if it's the JS plus the integer, not the integer plus the JS. So you think, how are we going to solve that? Because what it's going to do is if you say 56 plus JS, it's going to go off to the integer class and look at the add method for the integer class, and that's not going to work. But what happens is if the add method doesn't work in the integer class, it then goes to the other item here, Python does, and says, all right, add didn't work for integer plus string, but maybe Java string implements a thing called write add, which will be for integer plus string. So it'll look up write add next. Okay, and that in fact is our task 8. Implement enhanced Java string to handle expressions like int plus Java string. Yep. And so we have to implement radd. So let's copy and paste our class. We'll do the whole lot. And we'll implement in our class write add. So remember, this is only going to happen if the other class fails. So what we're going to do is return a Java string, and we're going to use the super.add, or we could have done it the other way. And we've just got to swap them round, so it's actually going to be a string of other dot add self. So yep, that now works. 56 plus JS gave us Java string 56 leading. Yep. So that's one way of doing it. Let's have a look at our solution. Another way of doing it, we've just defined a function radd here using format strings to do the other followed by the self. And then we've added it into our existing Java string class by just saying javastring.radd equals radd. And then that worked. Like I can just run this. It's not going to be clear whether the radds come from here or from here, but I can tell you that it works. Yep. All right. But the problem with what we have done is that all the string methods in the superclass return in string, not Java string. So if I was to go print js.upper, which is a string method for converting all the characters to uppercase, then it will return it. It will convert to uppercase, but it will return it as a string, not a Java string. Let's have a look at that. So js.upper, it was the word trailing in lowercase. It's now all uppercase, but the type of js.upper is class string. And I thought, well, that's going to be hard work because it means I've got to go through every single function that str implements and change the return type to be my new type. And I thought, well, that's not a very good example of inheritance, because when you're inheriting stuff, classes, you don't want to have to re-implement every single method. So I looked up the documentation, and sure enough, in the collections library that we've been using, there's a class called userString. And the point about userString was it provides userString to make subclassing a string easier. And I thought, wow, that's fantastic. Let's use userString and see how they do that. So I've created my new class, my userString, based on userString from collections. And all I've done at this stage, I've just changed the REPR so that when we find out how the data is represented internally, it'll return the word my userString followed by the super class REPR. So I create a variable called mus for my userString equals my userString leading, and then I do run upper and see how that works. And sure enough, it converts it all to uppercase, and the class is now my string. And I thought, wow, that's really clever. That's exactly what I needed. So I can see what they're saying. This userString is making subclassing string a lot easier. Okay, so Peter's asking what's the difference between a Java string and a Python string. So I'll just show an example of what we would do. Guardian A. So I'll do a Python string equals ABC. And if I say PS plus 4, I get an error. So that's how Python strings do. They go, if you're wanting to use the plus operator between a Python string and something else, it must be a string, not an integer. Now, if I wanted to do a Java string, and I'll use my existing class that I've defined called Java string, and it behaves like a Java string in Java does, and I do JS plus 4, then it gives me ABC4, which is what I was wanting from the Python string. So that's the difference between the way the two strings behave, and so that's the behavior I was trying to get into my new class Java string. But it was all going well until I discovered that if I called any of the string functions, my class, my object would lose its class because strings are immutable. Every function you call on it returns a brand new string, and it's returning a string of type str, not of type Java string. Is that clear? So then we're looking at this example here of my user string, which is implementing user string, which is purely, it's supposed to do everything that str does, but it's just designed to make subclassing it easier. And because that was exactly what my problem was, I was having trouble subclassing str, so I thought, fantastic, I'll use my user string for that. And sure enough, I can call the upper function, and the new function that the new string that it returns is actually of my class, my user string. So that's brilliant. That's exactly what I need, because then I can keep adding. Once I add my extra functionality to it, I can keep doing things on it, and it will maintain. Its class. So Peter's saying, is it common to mix Python strings and Java strings in Python coding? No, it's not. It's not a thing you would do. What I'm really talking from the perspective of, I'm a Java programmer who's trying to write a Python program, and I've got my Java code, and that I'm trying to convert over, and there's things that I'm doing in it that in Python are crashing, throwing exceptions. So I'm trying to create a new class to do what is in the Java, mainly because I don't understand Python. It's an example for someone who doesn't understand Python. So they are trying to get some of the things they like out of Java. Well, maybe they understand Python, they're just that these things they really liked in Java, they want them to be in Python as well. And then what makes it really funny, though, is that I then checked out how UserString worked, and it already has the Java string functionality. I didn't need to do anything to make it work. So obviously the people who wrote UserString liked that same functionality that Java strings have, and they've implemented it in UserString. I don't know whether it's by accident or by design. So for example, my user string leading +5 +4 gives me my user string leading 5 4. Now if you remember, my user string has got nothing in it. All it's got in it is this one function where I define the REPR of how it gets represented. So, technically I would call this a bug, that user string is got a different behavior to string, even though it's supposed to be exactly the same. But we'll probably find that in most cases it's actually what people want, because it's what I was trying to implement, but it's already been implemented. So the thing is, we can look at how they implemented it. So we've gone through our task to see how we would implement it. So let's see how they've done it in the collections library. And to do that, I'm going to use the inspect library. And inspect allows me to pull up the source code for any of these functions. Now, I've done it this way because I want this to work in just a normal Python script as well as in a Jupyter notebook. If you're doing Jupyter notebooks, you can use the double question mark to pull up source code. It's really just doing the same as what inspect is doing. Yes. All right, so let's have a look at the source code for userstring.add and userstring.writeAdd. Now, we were using duck typing, and they've gone and used isInstance. So you can see in this case they've decided isInstance is fine for what they need to do, and it probably is correct. There's only a couple of specific types that they need to worry about. Is it a string? Is it a user string? Is it a subclass of user string? So if the other, so remember we're passing in an int, is an instance of user string, which it's not, then we can, so we don't do this. If it's an instance of string, which it's not, no, so we do this. We do self.class, self.data plus string other. So they just convert it using the string function to a normal string, and then they run the add on self.data and string.other. So the way user string works, which is different to a normal string, is that they store the string itself in this property that's class variable of the class, or it's an instance variable of the class called data, and so that's going to be just a normal string, str string, and they've added it to this, converted the other to a string, which is the right-hand side of the plus sign, and then once they're both been strings, then it creates a new object of the current class. And this is really clever. Remember, the problem I was having was that I was returning strs, and so I then thought, well, I'll convert it to Java string, and then return a Java string. But if someone then went along and subclassed my Java string to something else, they'd be getting Java string from my methods, which is as useless as how string methods are returning str type objects. So by using self.class, it returns the same class as the starting object, which was either a Java string or a myUser string or a user string. And so it preserves the class, and it means that people who subclass this class don't have to re-implement every single method. And so that's how they've solved that problem. Similarly for the right add, so obviously left add hasn't worked, so they know that it's not a method of it's not a class of user string and not an instance of user string, so they don't even have to test for that. They just test for string, and then if that doesn't work, then they convert other to a string and then add it, which we'll call this. Okay, so that's the end of my duck typing talk. If you've got any questions on that, I hope you found it useful. I hope you can see where you might want to do this sort of thing. There's a lot you can do with exceptions, trying and catching exceptions, and not even just for duck typing. You'd use it in your code quite a lot as well. That's a really powerful feature. It's really important not to swallow exceptions all the time, which means if some people just catch every exception because they hate it when their program stops working, but then they don't provide any output or logging that there's been a problem, and so no one will ever get prompted to fix any code for particular situations that might be coming up, and quite serious errors can get hidden. So don't just swallow every exception. Make sure you only swallow specific exceptions that you want that you know exactly what's happening, and you're quite happy for the code to keep continuing, and that's what you want it to do. When you do a try, don't put a try around a big code block, because the exception could have it at any line within that code block. So try to only just use as few lines as possible within the try code block, so that it doesn't, you know that the exception has occurred in one of those lines that are in that code block. And feel free to use his instance as well if you think that that's going to provide enough, cover enough classes for what you're trying to do. Any more questions? Okay, I'll stay on the Slack chat for a few more minutes, so if you've got any questions there, you can ask me. As soon as I stop this video, I think the YouTube chat will stop working. But I hope you found that interesting. Next week will be an absolute beginner's session, so we'll probably just look at how to write functions, and look at some data types like dictionaries in a bit more at a simpler level than what we've done tonight. But even if it's people are having trouble just running Python, then we'll cater for any questions they've got with doing that. It'll all be done in Google Colab again, so you don't need to install Python on your computer. But having a Google Colab account will make it easier. Thank you.